border gateway protocol. It is autonomous system. That is, first we have to know about the autonomous system before going to border gateway protocol. Autonomous system is nothing but the collection of networks managed under the single administration. So we are having two types of dynamic routing protocol. One is interior gateway protocol and exterior gateway protocol. Interior gateway protocols are OSPF, ISIS, EIGRP, RIP and IGRP. Exterior gateway protocols are, that is only one, BGP. So before studying about BGP, we should know about the path vector routing protocol. So we have seen that distance vector routing protocol and link state routing protocol are the intra-domain routing protocols. Intra-domain routing protocols means that is used within the autonomous system. So the disadvantage of DVR is instability, that is infinite loop, count to infinity problem. Okay. And the disadvantage of link state routing protocol is flooding. When heavy traffic occurs, it leads to flooding. So to overcome these issues, we are going for inter-domain routing protocol. Path vector routing is the inter-domain routing protocol that is used between the autonomous system. Okay. So we are having a speaker node in each autonomous system acts on behalf of the entire autonomous system. So it creates routing table and advertise to speaker nodes in the neighboring AS. Okay, initialization. So each speaker node knows that only the reachability of nodes inside its autonomous system. For example, I am having A1, B1, C1 and D1 as the speaker nodes. So as we saw that autonomous system is the collection or group of routers within a single administration. Here we are having 5 routers, A1, A2, A3, A4 and A5. So we have taken that A1 as the speaker node which shares the information with the neighboring autonomous systems, that is AS3 and AS2. So AS2, B1 is the speaker node. For AS3, C1 is the speaker node and AS4, D1 is the speaker node. So we have to first write about the AS1 table. Our destination is from AS1, we are having speaker node A1. So the path is AS1. So for A2 also we are having the path AS1 because everything exists within the single autonomous system. So the path is AS1. So for example, we take B1. So for B1, B2, B3 and B4 are existing in the autonomous system AS2 and AS3. So C1, C2 and C3. Everything exists inside AS3. D1, D2, D3, D4 that exists inside AS4, the autonomous system. So AS autonomous system shares its tables with immediate neighbors. A1 shares the information with C1 and B1. C1 shares the information with D1 and A1. B1 shares the information with A1 and C1. D1 shares the information with only C1 because C1 is the only neighbor to D1. Likewise, it updates. Here it avoids looping. How it avoids looping? It updates its tables by adding nodes that are not in the routing table and it adds its own autonomous system inside its neighbor autonomous system. Loop prevention. So it avoids infinite loop if and only if it has any changes in the router, that is route addition or deletion or anything happens within the router, then only it updates the routing table. That is, updation of routing table is not periodic. So it avoids loop prevention. The next one is policy routing. So it is easily implemented through path vector routing. When router receives a message, it checks the paths. If it is against the policy, it ignores the path. Okay, next one is optimum path. For example, the path that fits the organization. Here, no metric is used. For example, RIP, Routing Information Protocol, that uses hop count metrics, and OSPF, that uses minimum delay as a metric, but it don't uses any metrics. So it only checks the path that fits within the organization. So path from AS4 to AS1. Which one is the shortest path? It moves to AS4 to AS1. D1, that is AS3 and AS1. Else it can move to AS3, AS2 and AS1. But it prefers this route. This is the shortest path. AS4, AS3 and AS1. It is preferred.